Hi, good morning, everyone. My name is Kevin Weaver, President of Brewmation, and I'm here with Javian.
Hi, I'm JB, and I'm system sales for Brewmation. Been a home brewer for about a little over 10 years, and happy to tell you guys about adding distillation to your brewery.
All right. So yeah, I appreciate everybody coming out. It's a little bit earlier for some than others. I know Javian's out on the West Coast, so it's nice and early for him. I'm out on the East Coast here, so it's not too bad. But we want to welcome everybody. Appreciate you coming in and attending the adding distillation to your brewery. It's certainly something that has been gaining a lot of traction and a lot of interest as well, because it certainly adds a lot of potential to breweries, and it might be a lot easier than most folks would think. Um, so just to kind of go over a little bit about what we're going to talk about, Javian's going to go through some distilling 101 for brewers, so you have a good idea, if you're not already, on how the whole process works. Some good points on why breweries add distilling. I'm going to come back in here and talk about what equipment is required, and hopefully you'll find that you have quite a bit of the equipment already. Some other additional considerations we'll go over, and then Javian's going to jump back in and talk a little bit more about some of the ins and outs on what to do and how to move forward. So Javian, I'll go ahead and pass it on to you, and I'm going to take my video off, and so you guys have a little bit more room.
Perfect. Thanks, Kevin. I'm going to go ahead and turn my video off too, just to make the presentation a little bit bigger here. Talk about a brief kind of high-level overview of distilling. For brewers, just to kind of tell you some of the differences, some of the things to look out for, some of the things you may know, some of the things you may not know. In distillation, the process is very similar to brewing. So you're going to have, your mash, you're going to ferment, then you distill the product, and then you package the product. That's very close to what you're doing in brewing. So, but there are some different goals in each of these steps than there are in brewing. So, for instance, in distilling, when you're mashing, your goal is really to produce a highly fermentable wort. You're going to use kind of lower mash temperatures to do that. So you're going to be in the kind of 147 to 149 range. Basically, their goal is to get as many sugars as possible out of the grain so that they can convert all those sugars to alcohol. And that's, their final product. That's what they're looking for. So some of the types of things you're going to be mashing will be the same. So you may still be mashing barley if you're doing like a whiskey or a bourbon. But you may add some other things like rye or corn, potato. For some spirits, you may even be using like just pure sugar, cane sugar. Just kind of depends on what your end goal is for the end product. So some of the stuff would be the same, some would be a little bit different. And then sometimes they skip the mashing altogether and they'll just buy neutral grain spirits, which are essentially a wash or a beer that they're going to just distill from that product. And that allows a distillery to get started with less equipment. And then, just like you would in brewing, you're going to occasionally with distilling lauter and chill. Some distillers will actually just move straight from the mash to fermentation. There are some benefits there to that. One is you don't have to mash as long. So as a distiller, you can move the mash straight to the fermenter and you're still having conversion happening during that process. So you can save some time and do a much shorter mash. Basically just makes the whole brew day a little bit shorter. But just like brewing, a lot of distillers will still lauter, remove the grain from the wort, and then chill it down to whatever pitching temperature they want. And then in fermentation, some of the key differences there, distilling, they have a much shorter fermentation time. Usually it's like 2 to 3 days, could be 3, 4, 5 days. So pretty short time there. You're also fermenting a little bit warmer. So they're generally in the 70 to 90 degree range. Whereas, most beers outside of Belgians are going to be, closer to that 65 to 68, unless you're doing a lager, which would be even lower, in the 50s. And then the final product they're producing is called wash. Whereas in brewing, you're obviously producing a beer. One other thing to note is that some products and some distillers have a preference of fermenting on the grain and potentially even distilling on the grain. And that's just to add some additional character. But also while doing that, you got to keep in mind that if you're going to do it that way, you're probably also going to carry over some off flavors that you'll have to age out. So you typically would see this on something that's definitely going to be aged, like a whiskey or a bourbon. And then here's one of the differences in the next step is instead of moving on to, packaging right now, you're going to move on to distillation. So basically you're going to run that wash product through your still. The goal here is to separate the ethanol from the wash to create your final spirit. And then the, potentially different mashes are going to produce different spirits. And then you might have a different distillation process as well. So you may run it through just a pot still to get, a simple full flavored spirit like a bourbon or a rum. Or you may run it through a big column to create a more neutral spirit like gin or vodka. And then your configuration of your still, then, kind of as I just mentioned, would be different depending on what kind of end product you're making. So if you want a full range of stuff, you'll probably end up going with a column still, just because you can make just about anything with that. But if you're really hyper focused on something like rum or bourbon and whiskey, then you might just have a pot still. Then there's an intermediate step that sometimes happens between distillation and packaging, which is your aging. So a neutral spirit like vodka or gin, you're obviously not going to age. But some of the, very sought after, very delicious spirits like bourbon and scotch, cognac and rum, there may be an aging process there between your distillation and your packaging. And how that differs from brewing, you guys are generally, I think, looks like many of you have a brewery or looking to start a brew distillery. So you probably know this process a little bit better. Brewing, it's, mash, louder, then you're going to boil, ferment. You may age depending on the product and then package. But you're doing so with slightly different goals in mind. So for mashing, our wort production is very fine tuned for the specific beer, the desired flavor, mouthfeel, color, and fermentability that you want in brewing. You may want a dry beer versus sweet beer, which determines your mash temperature. You may be going for a certain mouthfeel, which also may be affected by the mash temperature. So we control that very, very precisely in brewing. Also, lautering, this typically not an optional step in brewing. You're pretty much always going to remove the grain from the from the wort and then move on to chilling. And for brewing, we don't always want the most fermentable wort. Sometimes we want some sugars left in there and some to create a thicker beer. And like I said, this is optional for distilling, depending on what kind of product you're making. But in brewing, it's essentially necessary. A step that you don't do in distilling typically is boil. And the reason we do that in brewing is to isomerize hops and to reduce SMM, which is a DMS precursor. Maybe not as big a deal today with some of the highly modified malts we have. But still, those are the two main reasons we do it, and to sanitize the product before it moves on to the fermenter. Then you chill to your pitch temp, move the product over to your fermenters for fermentation. And our goal in brewing is, again, we're controlling temperatures a little bit more precisely than a distiller would. And that is for reducing off flavors. A lot of distillers have a mindset of just produce the product and the still will get rid of all the off flavors. Whereas brewing, we're not distilling anything, so every step is kind of fine tuned to reduce off flavors. Sometimes your fermentation will be pressure regulated, depending if you're fermenting under pressure or if you're going to use like a spunning valve to carbonate at the end. And I think this is arguably in brewing, the most important step is your fermentation. So it's a longer, slower process designed to keep yeast happy and develop the flavors you want and keep out the flavors you don't want. If you age your beer, then that would be the next step, which would be something you do with imperial stouts and porters, potentially sour beer, some experimental beers. You would also be doing that in, and then you move on to your packaging. And also a little bit different here. There's a lot of packaging options in beer. You can serve from a serving tank. You can put it in a keg, a can, a bottle. Whereas in distilling, you're typically just seeing bottles that are not pressure rated and most typically in 750 milliliters. Some of the key takeaways there is, brewing versus distilling. Your grain to glass time for distilling is, with not accounting for any aging you might be doing, is about 4 to 7 days, maybe 10 days max. Whereas brewing, you're more in the 10 to 14 days, maybe a little longer for a bigger beer. Equipment differences or equipment requirements. Distilling, you're looking at most basically a mash tun, fermenter, still. You might need an HLT depending on your process. You might have a on-demand water heater. You might be heating water in the mash tun. So pretty basic in terms of what equipment you need. Brewing, typically a lot more stuff. So you have your hot liquor tank, your mash tun, boil kettle, fermenter, bright tank. So there's a little bit more equipment in brewing. The production cost versus unit cost. So in distilling and brewing, your production cost per batch is going to be the same for the same volume typically. The cost of raw materials is about the same. But the end product for distilling, you're going to have a product that nets a lot more money per ounce. And brewing, you're going to have a product that produces less money per ounce. But you're going to have a lot less of the product in distilling and a lot more of it in brewing. So it's, kind of a wash there in terms of how much you make per batch. And that's what this next part talks about as well, is the relative revenue per volume, high revenue product in distilling, a lower revenue product for brewing. And so key takeaways, basically, just to give you kind of idea, if you're going into this, things you need to think about are you going to potentially have some different ingredients. You're going to have to either learn some new processes or hire somebody that knows those processes and build that into your business. If you're an existing brewery, you definitely need some additional equipment, but you're going to have most of this equipment already. So that's one of the reasons it really makes a lot of sense to add distilling. So some different equipment, but you may have some of it. Different production time. So something you need to think about when you're planning out your months is figuring out which tanks are going to be dedicated to which products, because they have different time schedules. There's a different, potentially a different cost to produce depending on what you're distilling versus what you're brewing. The products are going to sell at different prices, and they have kind of different floor space and safety requirements as well. Distilling has, in a lot of ways can be more dangerous than brewing is. So you have to take those safety requirements into consideration, as well as some additional floor space you may need, or different, potentially different build out you may need to put that equipment in your brewery. So basically understanding these differences and how they affect your current brewery and production schedule is the best way to kind of plan moving forward on if you want to do this and how you want to do it. So now that you kind of understand kind of the top level basics of distilling and how it's different from brewing, why would you even want to add distilling, right? Well, it comes down to a few things. Number one, product diversification. So, and if you have just a brewery, your product diversification is all essentially just different beers, right? So you have a stout, you have an IPA, you have a saison. That's how you're diversifying your products. If you add distilling, now you can add, a gin and a whiskey and a bourbon, potentially a hand sanitizer. You can add all these other products, and maybe one of these products becomes your go-to, maybe it was your IPA that was selling really high, and but now you have a whiskey that's incredible, and so now your whiskey is also selling an incredible amount. Just gives you some more options, a way to serve more customers, and it's kind of cool, right? Another reason to diversify is it's a crowded market right now. Craft brewing is still growing, but it's growing much more slowly than it was in the past. Still on the rise, but yeah, it's slowed a little bit. So to appeal to like a wider audience, adding distillation is a good way to do that. You could be the next best whiskey, the next best bourbon, next best tequila. Especially in markets like Portland, San Diego, Minneapolis, these kind of early adopters of craft beer. Things are so competitive there that it's even hard to open a brewery anymore. So a stat that I saw from the Brewers Association is that craft beer grew by, I think, 4% last year, which is a lot less than in previous years, whereas craft distilleries grew by 15.5%. So there's obviously a huge demand for craft distilling. And just to take one kind of distilling product, gin alone grew by 14.7%, almost 15%, from 2018 to 2019. So there's a big growing market there just for that one product. So now that you've diversified your products, what you're also doing is diversifying your profit centers. So the ways that you make money. So, even in non-COVID-19 times, having a wider range of products, helps to insulate you from, just a decline in craft beer or, other things that may happen in your business. Maybe you get hurt or some key employee gets hurt and it costs you money or leaves your company, and it costs you money to hire and replace that person. Having extra profit from other profit centers can help alleviate some of that stress. In addition, when you are in a crazy time like right now with COVID-19, you're seeing a lot of these distilleries are turning towards making things like hand sanitizer. Some of them are selling it, so it's a great way to make some additional money when things are really hard. And some of the distilleries in an even better position financially are giving it away for free to those who need it. So not just as a good way to make more money, but it's a great way to help the community and help your community. We did a poll of distilleries, kind of just asking what they thought the most important part of adding a distillery to their brewery was. And, unanimously, they said it was diversification of income streams, just a way to get more money and reduce that risk. And then my favorite reason why you should add a distillery if you already have a brewery is you kind of have a lot of the equipment already in place. So there's some, economies, not of scale, but of having that equipment already in place, that really all you need to add is essentially a still, right? Excuse me. And because you're, as we talked about before, we're already controlling temperatures really precisely in the mash and in the fermenter. You're producing wort and beer that is very high quality, and what can be considered a really high quality wash. So if you're already doing these things, best practices, when you distill it, you're going to end up with a better quality product. So I have the mentality of, good in, good out. So some, as I mentioned earlier, some distillers just rely on the distillation process to remove a lot of the off flavors and components that you don't want in your final product. But that doesn't work all the way, right? It'll get most of it out, but some of it will still be there, which is why it's, primarily the reason that some of these spirits actually need to be aged at all is because there's things in there that you need to age out. And if you're already producing incredible quality wash or incredible quality beer, then I think you got a leg up on a lot of these craft distilleries. So next we're going to talk about some of the equipment that you need and how it works and what it looks like. And so I'm going to pass over to Kevin to take on from there.
Excellent. Thanks, Fabian. That was great precursor here up to talking about some of the equipment. So I'm going to get right into it. Turn off my webcam. Just want to say hello to a couple newcomers that came in. So got some folks from far and wide. Got some Costa Rica. I think we might even have Mexico. But anyway, welcome again, everybody. I'm going to turn my camera off and talk a little bit more, dig into some details on the equipment. All right, so JB talked quite a bit about having equipment in your brewery already. So I'm going to also talk about what equipment is needed. So it's a little bit of a combo. So if there's some folks there that are not a brewery and looking to start a distillery, you should draw some good information out of this. But also as far as having equipment already, I'll go into a little bit about what equipment can be used and what tweaks can be done in order to reuse and create some different processes. So really the end product in the distilling process does drive some of the equipment needs. And we'll get into that as we go through, but the process starting here from the beginning. In a brewery, you're going to have a hot liquor tank, you're going to have a mash tun. If you don't have a hot liquor tank, you may have an on-demand heater as an example. So different. Basically, you need that hot water. If you have a hot liquor tank, then you're going to be able to make some adjustments to your water, adding various ingredients to balance it, get different profiles, etc. So I would say the vast majority of the breweries do have hot liquor tanks, and they are treating their water. So hot liquor tank would be there, and then moving over to the mash tun, there's some different designs out there. So. And back to the process driving the equipment, the two generalized methods of distilling would be either you're going to distill a clean wash that is basically sparge, just like you would in a brewing process, or you might be distilling with the grains in, so kind of a grain in or grain out type of distilling. So if you have a mash tun already and your desire is to do a grain in, that could present a couple of difficulties. You might have false bottom that's permanent that you can't remove. So it'd be impossible if you have the false bottom, without some modifications to get that grain out of the mash tun and then over into the fermenter. If you're going to be doing a sparge, and there's a lot of schools of thought out there about sparging, then you're going to be able to sparge and come up with a nice cleaner wash. Some folks want that character though of the in grain. So it's a decision that really has to be made. Now, since we're not boiling in this process, we're going to go right from the mash tun to fermentation. Then what we have is a couple options. So you could cool in the mash tun. We have mash tuns that have double jackets on them, so you could heat and cool in the mash tun. Now, likely you won't have that in the brewing space. So in that case, you're going to want to do some cooling. So if you're going to be doing a grain in, that next, you have three pieces of equipment stacked up there in the middle. One's a plate chiller, which most of us know. The one above that is a tube and shell, and above that is showing an inline strainer. So I'll talk about that a little bit. But if you're doing grain in, then you can't pump your grains through a plate chiller. So what you would end up doing is using that tube and shell, and that tube and shell is basically a long tube that continuously flows through in different angles, and it will cool it as it goes through and go into the fermenter. Grains and all, you're basically pumping the whole mass. And obviously you need a different pump than typically you would have, or some of you do have a separate lauter tun, so then that would be nice and easy because you could just go ahead and skip the lauter tun, go right through the tube and shell like you've been doing otherwise, and then go right into the fermenter. If you want to kind of stick with your standard equipment, if you have a plate chiller and you are sparging, then you can pump your sparge liquid right straight through the plate chiller. But there's a couple things there to be cautious of. And, as we know, sometimes we do get some grains that get through a false bottom, depends on how the false bottom fits, et cetera. So we don't want to go ahead and plug up the plate chiller. So that's where that inline strainer comes in. We basically size that strainer so that the holes are slightly smaller than what can pass through the plate chiller. And there's not a, hopefully there's not a lot coming through. If there is, then that's something that would need to be rectified. But having that strainer will protect your plate chiller and allow you to pump through and pump through the plate chiller right into the fermenter, so you're at the perfect fermentation temperatures. Another consideration is to have a nice even flow coming through there. So typically we would try to use perhaps even a peristaltic pump for the sparging, because it's a positive displacement. And that peristaltic pump will be nice with the ability to have a nice even flow and push through the plate chiller into the fermenter. So moving over to the fermenters, and there's two types of fermenters. The typical one that you'd have in your brewery, which is pictured dead center on the screen there. And then there's one that would have an agitator in it, the one to the right of that. So if you're just doing a standard sparge, then the standard fermenter will do the trick, and you're going to ferment like you would, typically would. There's no additional equipment that would be needed there. If you are doing grain in, and you're going to want a fermenter that has the agitator in it, that's going to allow you to move that product along. It's going to be able to mix, keep things fluid, etc. So that might be an addition, but since you already have the equipment, again, schools of thought, but you may have a nice clean fermentation, using a nice clean sparged wort. Then from there you go into the still. So again, grain in, you're going to continue that grain that's fermented and pump it right into the still. And we'll talk a little bit more about the distillation here in one of the next slides. So actually I'm just going to go back here real quick just to summarize. If you really take a look at this, if you have your own brewery, like we've been talking about, you have a hot liquor tank, you have a mash tun, you have plate chiller that we could go through and maybe just add a strainer, a pump. Then you got your fermenter that you would have, and then from the fermenter, you're just going to pump into the still. So basically everything leading up to the still you have. Another item I forgot to mention is the chilling, and we'll talk about that in a little bit more detail. But typically you're going to have a glycol chiller, and then we have to look at the capacity of that glycol chiller to see if it's able to handle the distillation requirements. So we'll talk about the components in the still and what you need. And again, it depends on what your final product is. So we just put a picture up of a pretty basic still here, and but does have some of the features, and we'll kind of go through them. So when we put stills together, we start talking about the various products that you want to produce, what your goals are, but you're always going to have a pot. That's going to be holding your wash, and that's where we're going to heat it. Different heating mechanisms could be steam. So if you have a boiler, you can utilize that to heat the still, heat your wash. If you wanted to go electric, we would typically go with a bain-marie style, which is that jacket. And actually that picture is a bain-marie. If you kind of look above the jacket, you see a little funnel there. That's where you add the heating oil, which creates the jacket. And then at the bottom, if you see the rectangle, that's where the heating elements are. So we're heating the oil, that is the jacket, which will then therefore heat the wash. It's kind of a nice way to do it. Bain-marie has been around forever. For cooking, you've probably heard about it. Melting chocolate and things like that. But and the bain-marie is a nice, safe way to go, especially when you're looking at electric. Some more that we'll talk about here in a little bit. And it's also a gentle heat with a bain-marie. So if you're doing gins, and your process would be to have your botanicals in the pot as opposed to in a gin basket, some feel that that's a better way to go. A bain-marie is a nice way because you're not going to risk burning some of those botanicals that would be in there. And it doesn't have to be just gin. I mean, you guys, brewers, are the most creative bunch out there, and what's kind of neat is some of the spirits that are coming out of brew distilleries. So you could think of anything that you might want to put in there, and if a nice gentle heat is called for, then bain-marie is a nice way to go. But steam would be used as the other means. So that's the basics of the pot. So you're always going to have one. It's just a matter of choosing what kind of heating source that you use. Now the mixing motor, we have a little mixer in there, and that is an absolute necessity if you're doing grain in. If you're doing regular sparge wort, you don't necessarily need it, but it's nice to have because it does keep things moving. again, if you're doing botanicals, et cetera, in the pot, it's nice to get those, swirling around so you get a lot of surface area. But it also does help the heating because you're moving things, getting a nice even heat, which is really what you want as you start to liberate the alcohol out of the wash. But it's still something optional. When you start looking at trying to do this a little bit more on a budget, removing that mixer motor is certainly an option. There's tons of stills that are doing it that way. Okay. So now we look at the next couple pieces here. You have shown here is a helmet and a line arm. Now, there's so many different shapes of helmets that people come up with, and there's a lot of different chemistry type of reasons. There's, people swear by one style or the other. So, the helmet design is something to research and kind of look into to see, what might suit your needs. The one shown there is a pretty typical helmet style. And what that does is as the vapors, are going into the still, I'm not really going to get into a lot of the chemistry stuff, but it will certainly change some of the profiles. It will do some reflux to knock down that the alcohol back into liquid form, raising the boiling point, starts to do some purifications, et cetera. So it's kind of a first pass. It's definitely an art to that particular piece. And same with the line arm. There's different style line arms, the ones that tip down, ones that might just go horizontal. And most of the time, the helmets and line arms may have more to do with the various whiskeys that are being produced. Again, that's probably a whole seminar in itself about the ins and outs of these particular designs. But as you go through it, those are different options. I mean, if you're just making some straight vodka, you may not need some of this. And as you could see there, it's in this particular case, it's all copper. So that definitely adds to cost. Kind of the rule of thumb is copper up, stainless down, meaning that you have all your parts that are copper, for your vaporization. And then when you look over at the condenser, it's a stainless. And there's some reasons behind that. Copper has some properties that lend itself very nicely to the distilling operations. Okay, so moving on to the column. So in the column, it could be this particular one has 6 plates in it. I've seen columns with 20 plates. It really depends on what you're making. The more columns that you have, if you have something like 20 plates, you're certainly making, vodkas, gins, things along those lines. Because in essence, each one of those plates, each one of those circles that you see in there is in essence doing its own distillation. So as you go through, it's going to be distilling, getting reflux, knocking it back down. Some of it's going to be going back into the pot to be liberated, and that's going to work its way through all the plates. And in essence, very generalization, it's purifying that alcohol as it's being made. You could also have multiple columns after it goes through the first column, and then it can then go into the second column for further purification. So there's a lot of different things to consider there, and that's something to take a look at how many passes you're going to do. So in other words, sometimes you may end up doing just a stripping run. So if you see there's a 3-way valve right between the column and the condenser, sometimes you're going to skip the column altogether, especially on a first stripping run. You're going to want to get that alcohol level a lot higher and get ready for your spirit run. So you may do 4 stripping runs. And that's how you kind of size your pot, is to get enough stripping runs that then you have a spirit run that's going to fill up the pot for your actual spirit run. So there's definitely calculations in there as far as sizing concerns. We usually work through our customers on those, depending on how big your brewery is, how big your fermenters are, et cetera. So we can get good batch sizes and start talking about stripping runs and when you want to do your spirit run. Also up top, there's, I don't know if we show that on the next, we get right to the gin basket. But just below the gin basket, there's right at the top of the copper column, and this gets pronounced a bunch of different ways. I call it the deflator. Basically what that does is another cooling mechanism in there, which causes some more reflux and adds to some of the purification. So a lot of times that those vapors will be rising up through the different plates. And especially as you're starting up, to regulate some of your heads, you're going to be cooling that just to kind of run through your process one more time. And I am oversimplifying some of the chemistry there. So those of you out there who really know your distilling stuff, I'm just trying to keep it general. So the next piece here is the gin basket. This particular one, it's a small, very small still, this one, and we have the gin basket sitting up top. It's a nice, easy way, economical place to put the gin basket. It's not the most convenient, but since it's a small still, it's easy to get to. On the bigger stills, we'll put that gin basket down on the liquor locker, which is the square stainless piece down below. Some of them are large, depending on how many different additives. I mean, we call it a gin basket, and typically it is gin. You have your botanicals in there where the ethanol is flowing through the botanicals to pick up the juniper flavors and aromas. But you can really put anything in there. We have an R&D system here, and I'm going to put coffee beans in there and try it out. Maybe that's a horrible idea, but hey, that's the creativity in me that I want to try and make a nice coffee liqueur. But you could get very creative with a gin basket. You could put all sorts of different things in there, different flower flavors, really you name it. So that's definitely a nice creative way to go, to have that in the vapor path. And also it could be bypassed. So it's not that, you're always going to have to go through the gin basket. If you're going to make a straight up vodka, then, you would bypass that gin basket and just go straight to the condenser. But that's definitely a place that you can get very creative. And then, of course, there's the condenser. So now that we've liberated the alcohol, we have it in a gaseous form. We need to bring that back to a liquid form. So it's purified at that point. Depending on if you're doing a stripping run or a spirit run, or if sometimes you might do a third run for more concentrated spirits. But in any event, this is where we need to take that and turn it back into a liquid. So we're condensing it with either cold water, ethanol. We'll talk a little bit more about what cooling means that you could use. But that's where we're condensing the alcohol. And if you look down at the bottom, there's actually 3 ports on this particular still. You kind of see the white. There's a temperature probe we put in there for a safety monitor. But we have the 3 outputs that you could connect: your heads, your tails, and your hearts. Of course, would be what you're keeping. So you could all do that and just keep swapping in containers, or you could hook up 3 different containers and then judge which one you're going into. So cooling, we're gonna get into cooling here a little bit on the next slide. Now, cooling, there's 2 places that you're going to do the cooling on the still itself. We talked already about the mash tun. As far as brewers, you have a good idea about cooling that wort or cooling the mash tun. But what I'm kind of talking about here is what cooling you need for the still itself. We have the condenser. Obviously, that needs to be cooled, and also the deflator or deflamators. There may be 2 of them that need to be cooled. So there's different ways to do it. A lot of stills will use straight water, just run water through it during the entire process. And it's amazing how many people actually do it that way. The drawback, obviously, there is that you're using a ton of water to do that. I've talked to some, local distilleries. I say, my God, they even use water for cooling the fermenter. But they said our water costs are so low that this does not justify using the glycol chiller. But it is a ton of water. But yes, that is an option. You could use straight water. But the nice part now on the folks that already have a brewery that are looking to do distilling, you likely have cooling. And that's one of the things that you certainly want to consider is how much cooling do you have? Do you have enough? So when we look at that chiller capacity, and hopefully you have some extra in there, and especially if you're running a 2-stage plate chiller, you're likely going to have a bunch of extra capacity. And if you're not running that 2-stage plate chiller at the same time you're running your still, you may have enough capacity. So all that has to be looked into. But there are different ways for us to tap into that cooling capacity. We could use partially water, just like a 2-stage chiller. We could do some chilling with the water. We could do some chilling with the glycol chiller. This diagram that I have up there is a kind of a unique way to kind of separate a separate circuit for the still, but still using the same glycol loop that you have for all of your fermenters and bright tanks. So in essence, we would end up, as you see that heat exchanger down below, we're just running your glycol through the loop, turning it on and off through that heat exchanger, and then we're running its own cooling loop for the condenser. And what's nice about breaking it out that way is that you could also have a water in and water out situation where you could actually use water just in case your glycol chiller goes down in the middle of a run. You could certainly jump into that water, and we even automate that too. I mentioned earlier about monitoring the temperature of your parrot. That's the output of the still. If that starts to get too warm, then that tells us that the ethanol vapors are getting through the condenser and not condensing, and that's a dangerous situation. So in that case, we would trigger the water to make sure that we do chill that down and then do an automatic shutdown of the still. So this is just a nice idea, and I'm not saying this is an absolute must. It's just another way to integrate chilling of your still if you already have a chiller in place for the rest of your process. So some additional considerations. JB mentioned earlier a little bit about the safety aspects of running a still. So the big thing that hopefully everybody's thinking of is, hey, how is it dangerous? You're dealing with ethanol vapors and you're dealing with flammable ethanol. So is it dangerous? Well, yes, it could be. But if you do things right and you do things properly, it's not dangerous at all. And that is quite honestly one of the things that I see very commonly in still installations that are really not done right. And it could be dangerous, and you might hear or read about accidents that happen. I know I do, and I've done some talks on just this safety aspect alone. And it could be a real danger if you don't do it right. So I think there's a question that we're going to answer in the Q&A about, how long does it take to get the still up and running, till you get to your profit point. And a lot of times what happens is it takes a long time for still to get to be installed and be approved because they run into a lot of issues with fire inspectors, et cetera. So, that could delay you for a long time if you're not thinking along the lines of this particular safety aspect of your installation. So really what it comes down to is your fire codes. C1D2 is what that's called. It's the C1D2 is what the codes refer to as the classification of how explosive an environment is. So there's class 1 div 1, which is the most explosive. And what that means is that under regular operations, there will be explosive vapors in the air. That's not the case here. You're going to have vapors if something goes wrong, because what happened, the ethanol will actually vaporize at higher temperatures, and all those higher temperatures are happening within the still, and everything is a closed unit. But let's just say you have a leak in maybe a CIP arm, or like I said, your chiller shuts down unexpectedly, then you could have vapors that come out, and that's what the C1D2 is that you're only going to have vapors in the event that something goes wrong. That's the simple way to put it. So in the event that happens, there has to be enough safeties in place that you're not going to have an accident. That, sure, something happened, you had some vapors, not a big deal. They're going to be vented out. And let's just say they weren't vented out. Then if there was some kind of electrical failure on any of the probes in the still, then that's going to be mitigated because of some of the safety precautions that we put in. So ventilation is the first and foremost thing. You definitely have to have ventilation. There's actually ways to vent your space in an engineered fashion that would even eliminate the C1D2 classification. And that has to be done by an engineer to look at the space, look at the airflow, the makeup air, et cetera. So that's one way to do it, is to have an engineered solution on your vapors. And it still doesn't preclude doing the C1D2 on your electronics. So that's what I'm going to talk about a little bit here. So if you're in a C1D2 environment, what we call that, or what a lot of people call that red area that I have around that still, they call that, it's pretty harsh, but they call it the sombrero of death. What that means is around your distillation equipment, there's an area that if there's a leak, that's where those vapors are going to be. So 5 foot around the still, from any point of that still, if you kind of look around that area around it, that's where vapors could be leaking out, coming out of the still. But as they come out, what happens is the ethanol vapors are heavier than air. So they're going to drop down to the floor level and they'll start building up on the floor. So that's why they call it the sombrero, because the bottom area is 25 feet away from the still. So that area, 3 foot off the ground, 25 foot around your still area, is considered the C1D2 area. So those are the problem spots. Those are the areas that if there is an issue and there is a spark, then that's going to cause the explosion. So what we have to do is make sure that that C1D2 area is treated properly. One, you typically are going to have some ethanol sensors in there. They will pick up the ethanol vapors. They will go ahead and trigger additional ventilation. But what we do in our controls is, instead of having a control system that is completely C1D2 compliant, as far as being inside, that would actually be more of an explosion-proof box, which gets very, very expensive. We locate our controls just outside of that area. We're more than 3 feet above, and we're more than 5 feet away from the still. And what we're doing there is, now all the wires that go from that control panel into the still, what we need to do is use intrinsic barriers and also do wiring for explosion proof. So that first picture up in the upper right shows heating elements that are in a bain-marie with the explosion proof boxes, and then also the proper wiring that's in a C1D2. So if something were to happen to that element, you're protected. It's not going to cause any issue, even if we had tons of ethanol, floating around in that area. The next thing is the sensors. So any sensors, temperature probes, pressure sensors, et cetera, that are on the still need to be protected, not only on themselves, but from any kind of short that might happen inside the control panel. So if there's a short in the control panel, we have what's called an intrinsic safety barrier. That safety barrier will take care of any surge of electricity, so there's no chance of any spark or anything happening at the sensor. So those intrinsic barriers need to be built into the control panel, and that's very key as you go through and start considering what your still design is going to be. And if you have somebody do the controls, make sure that they're UL 698, UL 508, which is typically in your brewing panels, is not going to be enough. The UL 698 is the UL version, and it could be CUL for Canada, UL for the US, and also actually all South America. I know we have someone from Mexico, Costa Rica, so the UL typically is fine and accepted in that area, but you have to have that UL 698 in order to properly install the intrinsic safety barriers. I'm going to turn it back over to Javian. 48-minute mark. We want to leave some room for questions, but Javian, go on in and you can take over from here.
For sure. Thanks, Kevin. So now you know kind of what you're in for. What's next if you want to move forward? So I think one of the most important things as far as next steps is going to be figuring out what your local regulations are, right? Federal regulations are pretty standard, across the country, but there may be some other barriers in your local area. So you want to figure out things like, can you even produce beer and spirits in the same location? Some places you can, some places you can't. Are you going to be able to sell through your current channels? So do you need to find new distributors? Can you sell through your tap room, both products? Can you sell direct to consumer? Do you have to have a restaurant in order to sell spirits? These are all things that exist. And so you need to figure out which ones apply to you in your area. So yeah, once you find that out, or while you're finding it out, you start making your plan, figure out what spirits you plan to make. You want to shortlist those. We had a question earlier about, since you have some of the brewing equipment already, does that make your return on investment faster? And it can. So if you're looking at making spirits that can be produced in a shorter amount of time, like vodka and gin, then absolutely you can start making money on those products pretty quickly. So having some of that equipment reduce your outlay for new equipment, to basically just distill, setting aside some area, making sure that you're following the local codes, any build out that may be necessary, and maybe a diaphragm pump, and then you can get started. If you're looking to make some stuff that's kind of longer term, still you probably have a better return on investment by adding a still, but that your return on investment is still going to take a while because stuff like bourbon, you're looking at a minimum of 2 years of aging that, usually 4+. If it's less than 4 years, you have to put a label on it that says it hasn't been aged to the 4-year mark. So that longer term stuff, it's going to take a while to get your money back on that. Then you want to figure out what system is the right size for you. So if you already have an existing brewery, I think that's generally pretty easy. You probably just go whatever the double size your fermenters is, or excuse me, double size your brew house. So you get some double size fermenters compared to your brew house, and that's probably the size you want to start at. But you also want to do some calculations and figure out your ROI, how much it's going to cost you for equipment if you need new equipment, and make those determinations based on that info. So this is a good place to start to figure out what your production goals are, if you can meet them with your current equipment, your current brew house and fermenters, or if you need to add like a bigger brew house or bigger equipment there as well. Then you want to evaluate your space. Do you have room for the equipment? As we mentioned earlier, can you put the equipment in the same room as your brewing equipment? How are you going to make sure you have the area for the C1D2 safety requirements? These are all things that you need to think about and plan for if you're going to be adding distillation to your brewery. So, another thing you can do is get some equipment pricing from the right suppliers that kind of know this stuff and can keep you safe. So I'm going to put up a little link. If you want to schedule a one-on-one with me or somebody at Brewmation, you can definitely do that. And then we have some time for some questions.
All right. So I'm just kind of looking at we had the one question there. I believe we might have answered about, kind of talked about getting some profits, especially if you're doing white rum, vodka, and gin, getting them early. So as JB, I think, covered a lot of that. And also if you have a lot of the equipment already and you're really doing your homework as far as the installation, you could really get things going pretty quickly and get right to a profit. I think Ray also asked about some case studies. I don't know if we have any case studies available. We'll take a look at that. We do have your email address and see what we could put together for you. And we might be able to reach out to the community and some of our connections and see if we can get something to you. You're welcome.
Are there any other questions out there?
All right, a couple of questions just popped up. Maybe Javian, I'll let you talk about the wood chips a little bit on that. I think that's a nice question there. Nice way to go.
Yeah, that's a good question. I think it comes down to a few things. This can be personal preference. You can get kind of some of the same flavors using wood chips if you have the right ratio of wood chips to your product. I think that might be something you want to disclose to your customers, and I think some of them may be perfectly fine with that, and some people may not. So I think you need to look at your market, how mature it is, and if it's if that process fits with your space and what you want to do better. I think it's a personal preference thing.
And I think on the wood chip thing, there's a manufacturer, kind of a company that we talk with. They have fermenters that have aging barrels that are metal, but they have wood staves, if I said it right, in the sides, and that's a real slick way to do it and reuse. That's kind of neat. Can you make hand sanitizer? Yeah, absolutely. Something new that I've been taking a look at as far as the hand sanitizer, and I know there's some specific formulas that they want you to use, but absolutely you can make that in these systems. maybe JB a little bit on price ranges. It's a very, very broad spectrum there. It depends on the size, but I don't know if you have anything handy that you could throw out.
Yeah, it really kind of depends on what spirits you want to make, and what size, and what existing equipment you have. But if we're talking just the still, you can range probably anywhere from maybe like 20K to sky's the limit, depending on how big you want to go. Yeah, it's really going to come down to, do you want a pot still or a column still? What size do you want the still? What spirits you're going to make, because that will determine kind of if you're going to go with a pot still or a column still, and what processes and equipment you need there. So yeah, it's a huge range. It's going to depend on your personal situation.
And the level of controls does tie into that. So if you're looking for a very basic control panel, that could certainly save you quite a bit of money. One thing I certainly would encourage you not to do would be to not include all the intrinsic barriers and that, but there's some more economical control solutions. And then, you could really get into ones that with a touchscreen and PLC that could add to cost. So there's a pretty good range on the control side as well. And that's something that can be fit to your budget and still have all the safeties in it. So that's another consideration. Let's see here. Got a couple other questions here. Jamie, you want to talk about somewhere about the TTB input grains?
Yeah, let me see. TTB measuring the So I thought I read somewhere about the TTB measuring the input grains for taxation rather than the output. Are there any special considerations for managing the brewing side versus distilling with regards to the TTB? Honestly, I do not know the answer to that question. I could definitely, if you want to leave your email address, I can probably look into that for you and give you an answer, but I don't know that off the top of my head.
And then talking about a standard mash tun with watering of corn mash, require a solid separator. Kind of depends, I believe, on that with how you're actually milling the corn mash, because certainly that's going to be a lot thicker. And there are some different, solid separator is certainly something that can be done very easily. And there might require a little bit more equipment on that side of things. But we could certainly chat with you a little bit more about some of those options. But that's definitely a little bit more tricky there. Eski is asking if we made tequila or mezcal. I personally have not, but I know that folks would, certainly do make it with our equipment. But it's something that I think is quite an art that I can't myself say that I'm good at, and I do love my tequila. So, all right, but I think we're just about ready to run out of time here. But if certainly if you have more questions, or if we didn't answer your question good enough, please click on that link or go to the website vbrewcon, schedule a one-on-one. Javian or myself, we'd be happy to chat with you. We had this time really carved out to be at the CBC, and so we're available, and we love to talk. As you can tell, you've been listening to us for an hour. So feel free to click on that or shoot on over to the website. But thank you so much, everyone, for joining. Great questions, and hopefully you caught some value out of this, and you might have a new venture to go on.
Awesome. Thanks, everyone.
All right. Take care. Have a great day.